Hello, our most valued student. My name is Confident and welcome to the second part of this revision on electricity. And I told you guys you need to stay tuned. I already did the first part of this lesson, and in this lesson we are going to look at how to answer this question for engineering science N3 as you prepare for your exam. So what did I do? I did this one in question or in lesson 1. So if you didn't watch this one, go back to the first video, part 1, I'll call it, where we looked at kind of how we approach this lesson, and it was not difficult, but it was interesting, and I even gave extra notes here. This was the extra notes I wanted to give. So with that, let's look at this lesson. It says here, state one application of electrolysis. Okay guys, electrolysis, it's you can use it in different things, for electroplating. I think I'm right there. You can use it in purification of what? Of metals. You can use it in the what you call electrolysis. Yeah, electroplating, purification of metals. You can actually be so open, say chemical industry. Someone will just have to think about it, and then you can say in the metal industry. They will just have to say, just confuse them to say metal industry. It's too broad, but you got it. It's difficult to mark you wrong. Or they just give them a confusion, like say metal industry, chemical industry. But if you get the actual one, just check your textbook. All right, now look at this one. For the circuit diagram below, calculate. It's 13 marks, actually 12 because one is a total resistance of the circuit, total current of the circuit, voltage drop at 5 ohm resistor. You know what, these resistors, I'll just say, let's follow the flow of current in these resistors. If you followed my first lesson, I think you now know that I said I use conventional current. This is plus, this is minus. So this is my source, and current here is flowing this direction. I use that. So that's my IT. Right. So my current is gonna go inside. That's still my IT. But here things start happening. What happens? This current is going to split the IT. One of it will go through the 4 ohm. We call it I4. But this one will enter, I'll call it I don't even know. Let's call it I7 because it gets into the 7 ohm resistor. Now look at this, guys. This one will come out as I4, and here it will wait for that current, that I7. Remember that I7 there, it went on and did other things, so they will combine to become IT, and then that goes inside as IT. That's Kirchhoff to say current is more like conservation of current. Current coming out is current coming in. Now look, the interesting part is what happens after that here. That's where the confusion is. So you need to understand that whenever you are dealing, whatever you are dealing with, when you're finding the total current, the total resistance, it is what you're going to do here. Which resistance or resistor is what and what. So that is where the whole confusion was. But now the fact that I7 and I4, they like that, you automatically know that this section and this section, they are in parallel already because they've got different currents. But now what about here? Because this current comes here, in here it further splits. Our I7 will go there to become one of it I5, the other one becomes I8. It brings more confusion, but look at it. I8 comes out here, and I8 goes into I6. When you see the same current going into another current, it means you have got these two guys, you have got what is called series. You see, it's a series combination. Why? Because the same current is coming out. So here we don't know whether we say it's I6 or I8. It's one thing. So you can call it I6 or I8 when it's like that. I6 or I8. It means add them up so that they can become one thing. Now look at it. I5 will come here to combine with that. So it means the I8 and I5, they are in parallel, you see. So let's start. Where are we going to start? Start with the series. So what I'm going to do, I'm going to call it the RS. RS series is equal to R1, which is in this case, we're going to call it R8 plus R6. So it will be R8 plus R6. You guys, you know the series, right? Which is equal to 8 plus 6. And 8 plus 6 is 14 ohms. Right. So now we can redraw this diagram in a way. And when I'm redrawing this diagram, I will be having just this part. I think it's good that we redraw it so that you can have an idea. So I got something like this on this diagram. Okay, you know, I'm feeling lazy drawing this, but it's fine. Let's draw that. So don't worry with the accuracy. I'm just trying to bring a point across here. So I think this was what happened. And then here I got the 5 ohms that came in here. Alright, and then from there, am I right? Yes, and then the 7. Okay, this I must do it like this so that it makes sense. Perfect. Then after that, these were like this, and then there's something that we did. I added here. I'm just gonna use a different pen. Here there was this guy here. Alright, so I hope this is what is happening, and then we're gonna talk about this side. What is it? My 4, my 7, my 5. Let me check. My 4, my 7, my 5. Now 8 and 6. What has happened to 8 and 6? It has become what? Our 14. So there is our 14 here. You see that? Now if I follow the current that we did, we said this one was gonna be the what? I7. Still remember, just check. This one we said it was gonna be the I4. Let's forget about this because we're interested in this direction. Now here the current split. I7 1 became I5, and then this one we called it I8 and this, but now we can call it I14 now. So we can actually attack it from the end. Start there and start our what? We start our parallel. Don't start here, because if you use this as a parallel, there is a problem, because 7 is yet to split further. So which one do you start here? You start from the end going backwards. 7 split into I5 and I14. Start with it before you can use I4 and I7. Are you with me? So start with this part where you are going to say now, remember it's parallel. You're going to say I'll use this one to say 1 over RP is 1 over R5 plus 1 over R14. I sing that, and I told you RP. Therefore, you can say therefore RP it's 1 over. That 1 over makes you get rid of this 1. Okay? So it's 1 over, and then you say 1 over 5 plus 1 over 14. It makes you not forget that 1 over, and your answer becomes easier to come about. So what's my RP? Then I do that and use the part of says 1 over, and then remember it's 1 over and 1 fraction again. 1 over what? 5 plus 1 over 14. Do you see that? Because it gives you now the thing to say you get your total resistance, which is 3.684. 3.864. So we have got 3.864 what? Ohms. Guys, if you can pick up some slight noise from these kids talking, you hear someone says I win. It's my boys, guys. Sorry, I told them they need to go and shut up in the bedroom there. in their bedroom so that they don't make noise, so that I can record for you. You remember, I have you in mind. So I told them, guys, these guys are about to do their exams, so allow me to go and teach my students. They are still young. One is 5 years, the other one just turned 5, and the other one just turned 3. So you can imagine their mind is asking, what is he talking about? So apologies therefore for the background noise, but listen guys, I'm rooting out for you. Alright, so this we have done. Now what do we do from here? You do the same thing. I'm gonna redraw this. Now the thing is, what I like about it now, it's more controlled now. Let me just sketch it. You have this, your cell. Here we have our cell. Let me make it longer. We have our cell, and then after that you still maintain your 4 ohms. You see that? We still maintain your 7 ohms, but now look, we added that 5 and 14. You come here, in a way, we can do it like this if you want. But so that it doesn't confuse you, I just want to show you that it has become like this. It's now more like here, it's series now. See? And then this goes like this. I will give you enough chance to see this. It's more like you've got this now, where you have got the 4, the 7. Now that RP is 3.864. See what's happening. Then when you follow your current, it is splitting, still the same. I4 is still there, I7 is still there, but I7 enters, this I7, it enters into that part. It means they are now in series. Do you see that? So here, the good part is you can now focus on the series first, which will be your RS is equal to R7 plus that RP that we got, which is what? 7 plus 3,864. Do you see that? And then you get that, I think it will be 10,864 ohms. Are you with me? That's your RS here. Remember, you're continuing, so some of it will start confusing in a way, but as long as you're following up the right working out, they will pick it up to say from here. Just make sure that you are neat with your work. Now from here, where do we go? We are saying, I'm taking the same diagram now to say we had this part, right? And then we had the 4 here. And then after that, we had the what? Remember, we added that 7. So now, guess what? It's now simpler like this. This is what this whole thing is. It's simpler now like that. Then this is how this circuit finally has come up into, whereby here you have got your 4. Now this is our 10,864. So you've got I4 coming, and then you've got that I'll call it I 10.864 because I've been naming it. It will end up looking the same. Look, different currents, it means they are parallel. Then I will do the last one to say R. See, okay, I can just continue right and say R parallel. I told you the trick what I do. Then parallel, I say 1 over, because I've already not quoted the formula. It's 1 over 4 plus 1 over 10,864. Do you see how sometimes I just get the final answer quicker with that? So it gives me the answer straight away. RP is, but don't forget this 1 over, and don't write 1 over RP. So if you write 1 over RP, it will be wrong. You are finding RP straight away, which is 1 over 4 plus 1 over 10,864. Alright, then when I do ST is 2,9235. Let's round off, shift setup 6 to 3 decimal places, which is 2,924 ohms. Now you're asking, but that's the end. That is the end. Guess what? It's not the end. Why? Because they told us somewhere here there is an internal resistance. Let's go back to the question. there is an internal resistance, and did you pick it up? There it is. R, the small r there, is what? 0.4 ohms. Very important. That's why you need to study this carefully. So there is a hidden your 0.4 there. So what the final diagram like? The final diagram comes here to become this, and then you have what? You have this one, which we called it 2.924. Then after that you've got this small one here, which is 0.4. Are you getting that? Then look at it. These now, the resistance, the total resistance, that's your RT of the second, and this is your internal resistance, this is your small r. You have to now add them again to say R equivalent now is equal to 0.4 plus this RT is more like the external resistance, which is 2.924. Then you get your answer. Then you have got your equivalent resistance. In other questions they will say calculate the equivalent resistance. Some they say calculate the total, so don't forget it, plus 2.924. So what you get is 3.324. 3.324 ohms. So this then becomes, guys, our answer. This is our R equivalent. That's what they were looking for. Alright, how many marks? I know you're saying, for all the work, just 4 marks. It depends. Whatever you do will still guarantee you your 2 and the 6 marks. Alright, let's go there. 7.2.2. What are they looking for? The total current in the second. This one is not difficult. The moment they say total, I like the part of total current. What you do is you come up with your triangle. Remember, we need to find out current. Remember, V is I and R. You must know this triangle. It's there also in the formulas, but they want the current now. What is current? I is equal to, which is total current, is equal to V. You must also make it total voltage over R. You must make it RT. But now you're gonna argue with me to say, but say your RT is my R equivalent. Let's actually use this as my RT so that it makes more sense. Let's come here and say that's my total resistance, because the question was I must find, this one was more like a P. So this is my RT, my RT. Are you with me? That's my total what? That's my total resistance. So when I write that, it will be, in this case, IT is equal to, now listen guys, when they talk about the total voltage is the EMF, the electromotive force of the cell. This is the voltage when the cell is not functioning. The total voltage that you can get is the EMF. So that's your EMF over RT. Sometimes they use the word R equivalent. Are you with me? So let's go and look for the EMF in our cell. They told us that the EMF was 8 volts there. Are you with me? And then we know the other part. So we know it's 8 over, what about RT? You come back to that 3.324. Okay. Then it will give you your total current that is in this particular circuit. That one that is flowing. Remember, we're looking at the current flow. So it's 8 over 3.324. What am I getting? I'm getting 2.4067. Shift setup 6 3 decimal place, which is 2.407. 2.407 amps. You see, this is my total current flowing. Whenever I was saying let's follow the current, saying IT. So the current that is coming out here is the 2.47 here. That's the one we're talking about here. Is 2.47. I forgot the other word, but it's amps. That's the current here. The 2.47 is continuing all the way. Now, the question interesting to me is the 6 marks. That's what actually attracted my attention. This one. Look at it. I mean, it's, you think that you have done everything you need to do, but there comes this question. 7.2.3 voltage drop at 5 ohm resistor. We come to the 5 ohm resistor. They are talking about this guy, the voltage drop, meaning if we connect a voltmeter here, they are asking what will be the reading of this voltmeter here. That's all they are asking. If you connect a voltmeter, trust me, if you don't do it correct, you're gonna get things wrong here. But now the flow of my diagrams, they will help me a lot, because look, I'll start with this one. This one, I said there is I7 here. I'll use the red. I7 meaning current 7 entered. When current 7 entered, remember it was after splitting. We said what was the current? They told us we calculated the current to be 2,407, not 47. Here we said current coming in is 2,407. That way it's split now. It was splitting this 2,407. Some of it went into I7, some of it went into I4. Alright, so far so good. But in I7 it further split into I5 and I14. But there is something interesting about when you're talking about a voltmeter. When you connect your voltmeter across here and do this, and then say voltmeter here, the reading you get for I14 and I5 is the same. So which means V5 is equal to V14. Why? Because they are parallel. When they are parallel, the voltmeter is the same. Are you with me? Now further, it was also interesting to note that we can use this diagram here and focus. I said I'll use my red and focus on this total. Remember, 5 and 14, they gave us this total. These came together when you added parallel. It gave us this to say, if I can find my voltmeter here, put my voltmeter here, the voltmeter, these readings are the same readings. It's the same thing. Are you with me? It is the same thing. If I can do that, I will find the same reading. Now, you can also continue. It's interesting to say here, you see these ones, we added what? We added 7. We added what? We added we added the 7 and we added the 3,84. But we say the current entering I7 is the same current entering this parallel part. Remember, it entered I7, entered into I5 and I14, but when it combined as 3,84 is still I7. I can come to the next diagram. You see, I'm going from to the end where we had this scenario. We added this. Are you seeing that? And we said this current was splitting into I4, there it is, and I10. The I10 is actually, if you look at it, this I10 is my I7, this one. This is actually my I7. But I wanted to label it as I10. Why? Because I added 7 plus 3 to give me my what? My I10. It's the same current. So now, if I then accept that that's my what? That's my I10, I can even focus on saying even the voltmeter here, you know, I don't want to confuse you now. It will be the same, the reading on this voltmeter and that voltmeter. It is going to be the same in a way. But now, let's come back to this thing, guys. How do you work out this whole thing? Because you are saying, okay, you have got an EMF of 8 volts. Remember, EMF is 8 volts, but you must know when it's parallel here, it's the same voltage. So what I can do, I can focus on where? I can focus on this diagram and say, all right, I know that my I7 here, remember the I7 that entered here, if I can find the I7 that entered from here, we can find it actually from here. Let's find out this I7. How do you find out? You can use ratios like this. just pay attention now. I want you to pay attention. Don't lose me now. We can use ratios. Remember our triangle. This is our triangle. What did I say? VIR. Okay, so I can use it to say what is my current. Now I'm looking at my current. Let me use the same one. Now my current into let's just calculate the current. Current is equal to not current, it's yeah, let's use the current. Current is voltage over resistance. Let's use that, voltage over resistance. But now look at this, the voltage across here, there is EMF here. Remember that EMF? That EMF, it was 8 volts. Guess what? Because it's in parallel here, V, and that V is also 8 volts because it's in parallel. Parallel, remember, the 10, the 4, and the EMF, these are in parallel. So you come back and say here it's 8 over, right? I can start by looking at this 10, where I've got, I'm looking for I10 here, that I10,864. I think that. So the resistance there is that one of 10,864. Pay attention there, which is equal to, so it will give me the current that entered there only. Are you with me? So it's 8 over 10,864. What is the current that entered into that? It's 0.736. 0.736. So it's 0.736 amps. Whatever I calculated, look, I said, okay, we have an EMF, but this EMF is 8 volts. Now it's connected in parallel to the 4 using the last diagram, which is connected in parallel to the 10. So they share the same EMF. So after that, I will know the current, which is, I'm working backwards now. This 0.736, I work backwards and say, okay, if it the I10, I say this is same as I7. This is same as I10,864. So if we go to that I7, there we talk about I7. Look at this. In the second part of the diagram, there is I7. So we know there where there is that I7. Let me use something different. The current that entered there, which is I7, we said, what was it? That I7 is same as this is 0.736 here. I'm just trying to make it make sense to you. 0.736 amps is the current that entered there. It's the same current that splits there. See, the current there is 0.736. The other one went into this I4. But going backwards again, the interesting part is when this I7 entered as 0.736. Here, see, I7 here is 0.736. It went and split here. But now what is interesting is I don't need to know how it split. I can use this one here to say their resistance will be the same. So what is their combined? They combined to make what? They just combined to make 0.384. So I can say, okay, the 5 and the 14, and I know their current. So I've got something like this. Let me do it on top here. I've got something like this to say here. I've got the total, which is this one, 3.864. You see, 3.864, right? And then I've got current that entered, which was that I7. We know the current. What is the current? Which is 0. That's the current that entered, 0.736 amps. You see, now we say then find the voltage there. You see that when you calculate that voltage, it will be what? You use that triangle. Remember, we say the triangles like this, which is VIR. So you're like V is equal to I times R. Now what is the current, which is 0.736 times the resistance, which is 3,864. Then when you do that, let's look into that. It is going to be 0.736 times 3.864 equal to, there it is, voltage is 2.8439. Let's round off this thing into 3 decimal places. 2,844. It's 2,844 volts. You see, that is the voltage now in this 3,864. But guess what? That voltage here is the same voltage. Remember, parallel combination, they've got the same voltage. If it's in I14, if they say what is the voltage in V14, is equal to V5, which I did here, which is equal to, then what? There is the answer, 2,844. 2,8, let me use another pen there. It's 2,844 volts. That's what they wanted, guys, as the answer there. All right, I hope it does make sense. And then any other way of doing it, I will say yes, there is another way of doing it. Okay guys, we've come to the end of our lesson. Don't forget to subscribe. This is the 24-minute lesson, the lesson for the underdogs. It has you in mind. If you're not subscribing, you're not doing us a justice. Just subscribe and make sure that you share it to your friends, to your colleagues, so that they can also benefit. We have come to the end of our lesson. Thank you.